Alright guys, welcome back. We're going to be solving another question following the previous video where we solved question 233, and in this one we have a follow-up question to that one. And for the composite block that we had in the problem 233, we need to determine this time the value of the H. So these two, if the portion of the load carried by the aluminum is half of the portion of the load carried by the brass. So technically the load of aluminum is half of load of brass. We're just going to show it with PA for aluminum and PB for the load in brass. And in the second part of the question, the total load, if the stress in the brass is 80 megapascal. So for that one, we have an actual value for the stress of B, which is 80 megapascal. And if you remember the previous question, we had the deformation of the whole system, which we call it with delta, which was the deformation of the aluminum, and it will be the same as the deformation of the brass. And we're going to have a formula for each of these two, and based on that, we can figure out what should be this H. And we showed that the whole load would consist of the load that is applying on the aluminum plus the load on brass. But in the first part, we actually have some values, and we showed that the deformation in each of them would be the force that is applying. We have the formula PL over AE, PL over AE. This P is the force, so it's different than the overall load that we have. So for A, this is going to be PA times the length over area of the aluminum times the elastic modulus, and we can figure out the PA in here. So basically it's going to be the area times E over L. I missed the delta. I'm going to show all of the deformations with delta now because it's the same. And we're going to have the same story for PB as well. Slightly difference that the elastic modulus is different. Same deformation and same length. And they're both actually the 300 that we have in here. And we have this equation in here that actually PA is half of PB. So if we just use that equation that we had in here, it's going to show with star. So PA or AE, the area of the aluminum, elastic modulus, the length, delta is actually 1/2 of PB, area of the brass, elastic modulus of brass, and so we can cancel delta and L in here as it would be the same. And what's missing in here is the area of the aluminum because that would be the H. So we are interested in these areas, which would be basically 60 times H times 2 because we have 2. So if we just want to find the area of the aluminum, this would be 1/2 of AB times elastic modulus of B over EA. So we can find the area pretty easy. So 1/2 of the area of the brass is also this area. I'm going to show it with red so we can differentiate. So one side is 40, the other side is 60. So basically 40 times 60. Keep in mind that we need a unit conversion because it's in millimeter. So 10 to the minus 6 in order to get it in meter. We also have the elastic modulus of brass, 105 gigapascal, so times 105 10 to the 9 pascal for the giga, and we have also the elastic modulus of aluminum, 70 gigapascal, so times 70 10 to the 9 pascal. And now we can find the area of the aluminum, which as I said would be 2 times the H times the other side was 60 millimeters, so 60 times 10 to the minus 6, and this will be equal to whatever we have in here. So 40 times 60 times 10 to the minus 6 times 105 over 70. These two will be canceled out. This 60 can be canceled out in here too. And basically our H would be half of 40 times 105 divided by 70, and the 2 is going to go into the denominator. So let's just calculate this. 40 times 105 divided by 70 times 2, which is 140. So one thing was missing in here. We also have another 2 in here, which was this 2, which I missed. So here we're going to have another 2. So 30 needs to be divided by 2. And that's going to be 15. And the unit will be millimeter because we put everything in millimeter in here. So that's the answer for the A part of the question. For the B part, it's much easier. We have the stress in the brass. So it's 80, was it megapascal? Yeah, megapascal. So 10 to the 6 Pascal, which would be basically the force in brass. So PB over the area of the brass, which we already found. It would be the red part 60 times 40, 60 times 40 times 10 to the minus 6. And we can find the force in brass here. So it's 60 by 40. I just put both 40, so this will be 60. And we can find PB pretty easy. That's going to be, so these two will be canceled out, and we're going to have, so 80 times 40 times 60. This is going to give us 192 kilonewtons, and we know PA is equal to half of PB. So if we just divide this by 2, divide this by 2, this is going to give us 96 kilonewton for force in aluminum, and the overall load was PA plus PB, or 192 plus 96, 192 plus 96, which is going to be 288 kilonewton, and this would be the answer for the B part of the question. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next video. Have a good one.